When I say operations on decimals, what does that mean? Right. It's easier than you think. Haven't we talked about adding decimals? What's the rule for adding decimals? Very good. And place zeros anywhere that is needed to make them equal the same. So we line up the decimals. 3401. Since the top number has one extra, I got to put a 0 down here. And just add the columns. 5 plus 0, 4 plus 1, 1 plus 0, 0 plus 4, 2 plus 3, the decimal. So that's all there is to adding decimals. The same thing would go if we're doing manipulatives. We'd have the integers and the decimals and just add them. Once we reach 10, it carries over. The same thing we do here. Subtracting decimals. What do you think you do there? Let me look for first step. Take the sign of the larger decimal number. Subtract the smaller from the larger. Lining up the decimals. And placing zeros where needed. For example, 0.5149 minus 0.39261. So first step, which number is bigger, the 0.5 or 0.3? 0.5, and it's positive. So your answer is going to be positive. We know the answer is going to be positive. So we take the larger number, subtract the smaller number from it. Since this one has an extra, I got to put a 0 here. Now we subtract 0 minus 1. You can't do that, so you got to borrow. 10 minus 1 is 9. 8 minus 6 is 2. 4 minus 2 is 2. 1 minus 9, you can't do it, so I got to borrow 1. So now I have 11 minus 9 is 2. 4 minus 3 is 1. The decimals, and there's one, and it's positive. We do the same thing if we had them reversed. The first thing we got to do is, will the answer be positive or negative? Which number is bigger? The 0.5, and it's negative, so the answer is going to be negative. So now we take the bigger number and subtract the smaller number from it. And we'll get the same answer, except this one's going to be negative. That's adding and subtracting. How about multiplying? What's the rule for multiplying decimals? Yes, but there's an easier way. I'll show you. So we'll look at example 1. Or example 4, I mean. 6.2 times 1.43. Zero 0.02, 0.013. And then C will give us 1,000 times 3.6. That's an easy one. So what we're going to do here, the easiest way, because remember, up until this point, we taught the kids how to add, subtract, and multiply. So the steps here are remove the decimals. So this first one is 62 divided by 10. Since we only have to move it one space to the right, we divide it by 10. The second number, we have 143. We have to move it 2 decimal places, so it's 2 zeros on the bottom. These are the same numbers, right? So all we have to do now is multiply 62 times 143, 10 times 100, just count the number of zeros. So 143 times 62, 682, 1825. Carry the 1. So the top is 8866 over 1,000. Because the kids should know how to multiply already. We've done that a couple of times. So now we're dividing by 3 zeros. What does that 3 0 tell us to do? It says move the decimal 3 to the left. 8.866. It's reverse of what we've been doing, which is how we're supposed to do it. 0.02, 0.013. Do the same process. So this first one is 2 divided by what? How many spaces do we have to move it? So it's 2 zeros on the bottom. The top is 13. 1, 2, 3. 3 zeros on the bottom. Two times 13 is 100 times 1,000. 1 times 1 is 1, and just count the number of zeros. 5 zeros. I heard that. This is an easy one. Whenever you multiply large numbers, just count the number of zeros and put them back behind it. So we have 1, 2, 3, 4, 5, which means from 26, we have to move the decimal to the left 5 spaces. 1, 2, 3, 4, 5. So the answer is 0.00026. And C is pretty straightforward because now we're multiplying. Since we're multiplying, we got to move the decimal to the right 3 spaces. 1, 2, 3. When you multiply, you move to the right. When you divide, you move to the left. So far, so good. Right. I want to go a little further, but okay. We have 2 more things to talk about: scientific notation and division. So we'll do scientific notation today. We'll finish up. It won't take that long. And then we'll move on to division next time, and it will finish up the chapter. Okay. Who knows what scientific notation is?
When you set up, like, let's say I'm only 46 instead of 100 last time.
186,282.397. That's a pretty big number. So is 6.2 or 6.2. That's a pretty big number. 5, 6, 7, 8. So is that one. So scientific notation, you take very large and very small numbers and make them into something manageable. So since this one has a whole bunch of ones, it's mostly ones that have like this. what we would do, since this one has 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 3, 6, 9, says 12 zeros. Scientific notation has this format. Where you only have one non-zero digit to the left of the decimal. So with this one, it would be 6.2 times 10 to the n tells us how many spaces we have to move from the decimal to that location. So 3, 6, 9, 12, 13. So from 6.2 times 10 to the 13th, I know I got to move the decimal place to the right 13 spaces. It'll be that one. This one is going to be 3.5. Since I'm coming in from the left, 1, 2, 3, 4, 5, 6, 7, 8, 9. Since I'm coming in from the left, it's a small number. I got to make the number negative, the exponent negative. So you have a positive exponent if it's a large number. You have a negative if it's a small number. So what if we took these two numbers and multiplied them together? If we took 6,200 and 0.00035 and multiplied them together, it's a lot of writing. These would make it a lot easier to deal with. Remember our rule about multiplying decimals? If we move this one, or if we move this decimal from here to there, it's no longer 13. It's now, we subtract 1. We only got 12. So 62 times 10 to the 12th. Likewise with this one. We have 35 times 10 to the subtract 1 to the negative 10th. Whenever you move a decimal to the right, you subtract 1 from the scientific notation. Because instead of stopping at 9th, we have to go one more. It's 10. So here, all we have to do is multiply the numbers 62 times 35, 10 to the 12th times 10 to the negative 10. 62 times 35, 31, 6, 18. 2170. Since they're both base 10, add the exponents. So 12 minus 10 is 2. Is this number in scientific notation? No, because the decimal's over here. I got to move it over to 2.17. Since I moved it to the left, 3 spaces, I have to add 3. So there's my answer. We'll pick up from here next time. I know I went through it pretty quick, but we'll do these two type of equations again. So that's not, it takes very big numbers and very small numbers, makes them manageable that we can deal with in mathematics.